Alright, so this is 2021. Every time I refer to this paper, I keep saying 2022, so it feels weird. Q5. So real plus to real plus. And it's x squared plus x f of y equals f of x times x plus y. Like this. Yeah? Who's that, Leon? There you go.
Oh, this is just chord bashing. Very.
What is?
No, one. This is.
Oh no, you can do. So obviously you're meant to do one without chord bash, but as an exercise, you should be chord bashing it so that to prove to me your chord bash level is good enough.
To make sure my chord bash isn't trash. The ASC is easy.
Alright, so this is this question. Reals plus, so this is for all x, y, positive, basically.
Why would it be reals? Suspicious.
Yes, there is no zero, but
A, B, K, E, C. Wait.
Do you need paper?
Sus. Okay, prove that. Six. B, K, C, okay. What is this?
Oh. Okay, you got identity works.
Oh, wow. God, no way. No way.
There's no more, there can't be any more constants. That's what's why.
Word plus XY equals X squared. Yeah, okay.
Can't be any constants.
It works. No way. No way. We figured it out. 1 mark. 1 mark. 1 mark. Good job.
I forgot how small identity was.
Do I do?
And then we say it's non-constant, and that's another 1 mark. It's non-constant.
Oh wait. Okay. Oh wait.
Oh,
Huh?
wait.
Yeah, multiple revelations.
We may have done this.
That's kind of interesting.
Wait, share interesting.
Interesting. Okay. So you know F is injective?
What? Really?
What?
Do you?
Okay, let's go. Wow.
Okay, so if you sub y1 equals y2, like f of y1 equals f of y2, right?
Okay, I'll do A, B, F.
So you sub y equals a and y equals b in both. And you basically get that f of x by x plus a equals f of x by x plus b.
Oh. Okay.
So like that f of y goes, like you can sub y equals a in that first one.
Yep. X plus, and then it's A.
Yeah. And then the next one would be f of x by x plus b. And then basically you can deduce that a equals b.
Oh.
Because the f of a and the f of b on both the left hand sides are equal, right?
Uh-huh.
Mhm.
Let me get this.
They ring the doorbell. Kyle looks cooler.
Someone's holding the last question from ASC. Lucas is in the doing the Japan. Have you done last year's questions?
I didn't solve this one in the exam.
You did it afterwards.
It
Never came back.
I think CJ told me the solution.
Oh.
Yeah, I think
Oh,
we
we
shared all of our solutions. Daniel might have. Yeah. But it wasn't.
Okay, so basically you can see that f is injective, right?
Okay, so let's do this. So this is equal. This is equal.
Yeah.
Yeah. And these,
X is also
you
equal.
see, like you can do like x plus a equals x plus b. Yeah.
And bang.
So then
Wow.
a equals b. So then once you prove an injective, you can substitute
So
x
good.
equals y equals a half into the functional equation, and that's kind of useful because the f of x just goes to f of x. There's no term, and we can use injectivity. So if you sub x equals y equals a half, then you get f of a quarter plus a half f of a half equals f of a half, and you can cancel the x. It's the x on both sides.
Canceling f's.
So then you get a quarter plus a half. I mean, yeah, f of a half over 2 is equal to f of a half.
That means
F of a half equals a half. Yeah.
half of F of a.
So you get that f of a half equals a half, which is kind of neat.
Yes.
So then we can go back. We can go back and substitute y equals f of a half. I mean, x equals f of a half into the functional equation. And we get a quarter. I mean, f of a quarter plus a half.
So x equals f of a half.
X equals a half. I mean, x equals a half. Yeah. X equals a half. So we get f of a quarter plus a half f of y.
Nah. It's right.
Is equal to a half of a half plus y.
I understand, but how does he get the ideas from?
You know, you'd think that like because you guys just came in, she was doing this for a long time, but she wasn't.
The Elo actually feels Elo.
And f of a half is just a half. So we can like get rid of the f of a half and just add it in the, because like f of a half equals a half. So f of a half would also equal to a half.
Yes.
Then you get one quarter plus y.
And that's kind of interesting, but now this is like
That's what you're
all I got
up to.
up to. Yeah.
That's very interesting.
I feel like question 1's too perfect for code bash for me. No.
Oh.
It also proves subjectivity though.
Sort of.
Oh yeah, wait,
Wait,
because you got a
so-
quarter at the beginning.
Yeah.
Oh, that kind of
Oh,
ruins
so-
the subjectivity.
So it shows you the range is at least like a quarter
Yeah,
to infinity.
that's kind of neat though.
Indeed.
Wait, but it does mean that there's it does mean there's some x. That's a f of x equals 1.
And put F
F
of
of x.
K. Put K and
Sheesh. Okay.
F of K
Wait.
equals
Okay.
Right,
F of x
right.
equals 1.
Let's say that.
X equals 1. Okay. Then it's like x plus y equals. Wait.
Wait. Wait.
Equals f.
Silent.
Does that help?
Wait, maybe it doesn't.
Does that help?
I don't know if it does.
X of f.
Oh, wait a
What
second.
if we set
Wait a
everything to
second.
this? So then 2x equals f of 1 plus 1.
Wait a
X
second.
plus
What do
x.
we say? F of a quarter.
X. Okay. 2x equals f of x plus x. Wait, what? What? Did I do this right? I don't think.
Wait.
That's crazy. Okay. Hold on. If we let f of x and f of x equals y, f of x equals 1.
Say again, what are you saying?
Wait, no, I don't know this stuff. I need to. Does this help?
Yeah, so I guess it's kind of following your nose, right? She saw it was injective, and then using injective, trying to cancel the F somewhere.
What if you don't have
And
nose?
then knowing half, you want to put the half in somewhere, right? It's like
Gross. This is weird.
to chase.
No, this doesn't quite work.
Mm.
It's almost.
What is the pesky F of x?
Because, wait,
Wait.
so it's just x, okay. No, 2x. That doesn't quite help.
Try something X equals Y.
We tried that one. X equals y.
Oh yeah. The fact that it's positive. You can factorize the left. Wow. Positive Y. Oh yes.
Definitely. Okay.
My desperation is
So it's like 1 half. Oh. You're.
yo.
What? Did I do something? I think I did. Okay. Oh, wait, no, it's fine.
I'm drunk.
Let me do some writing.
Such that K such that K equals
Oh, that's not fine.
I don't think this really helps, but
Hmm.
Wait, what? How'd you get that?
I subbed F of K
Wait.
equals 1.
X equals F of K.
Yeah,
X equals what?
F of K such that
Wait, what the?
X equals F of K.
Wait, what? Wait,
Can't you just
wait, what's going on?
F of K, like X equals F of K, right? And then we just sub it into the first
Wait,
one.
what's happening?
But what's that? What do you mean F of K equals 1?
What's that?
Like K exists K such that.
Wait, can't
Wait,
you just
what?
put
Can't you just
X
put
equals
K
1?
in the? Wait, what? Wait, I'm so confused. What are you doing?
Making F of K equals
And the
What is going
overcomplicating-
on?
Assume F of K equals
What
1,
is
then
happening?
put in K.
What's
Dumb.
Are we putting K or F of K?
I just put X equals 1.
What is going on?
F of 1 plus F of Y
Wait.
Oh
equals
no, you've done something mildly suspicious.
1 plus 1.
Oh no.
Don't even cancel.
Wait, that's actually a nice sub.
Hmm.
Yes, I did something.
Wait, yeah, but what did that?
Hmm. So this is.
It's bleeding.
I
Always.
feel like I'm kind of
Your
screwed
gum.
if there's
Alright, then.
functional equations
What does it taste like?
because I don't know how to.
I think well, cancel.
Hmm.
Oh, good one. Stop white was hot as well.
Using Leon's thing as of 2 1 plus 2. No, it's safe. Okay. Leon,
Hmm.
what a great idea.
Leon is stunned.
No way. Right, now what do we do with this?
If you're pretending to be sarcastic and you bring it to the next generation, the next generation might actually believe this song.
Hmm.
I think we're getting here. So. What do you use S squared?
Hmm.
Oh,
2 plus.
at least it led me to a nice song, right?
Okay, no, that's not quite right. Wait. Really wrong.
Set. Yeah, I tried something X equals Y equals 1, and this is what I got.
1 plus. Wait.
With injective, can you like cancel it if even if it's like a multiplicative constant at the
What? This doesn't really do much. Wait. One.
But we tried again.
Yeah, so maybe one thing people can try and prove as a sort of a milestone is f of 1 equals 1.
F of 1 equals.
Oh,
Ooh.
I'm trying to.
I have no idea how to approach it. Okay, how do we make
I
this
got
F of
what
1?
F of 2 is.
Oh, wait, hold
Hey,
on.
yo.
Wait, did you?
What is it? 1 plus k?
1 plus a
One
F of
plus
F of 1.
Oh,
Hey yo.
1/2
Yo.
x.
And now we
X
assume that
squared
F of 1.
K.
F of L
X
equals
squared
2.
Plus 1 half x.
Looks like
X
1
squared plus x minus
F over L.
2.
Alright.
Okay.
Now.
Wait. Can we even factorize this? Wait a minute, we need some quadratic solution.
F over L.
What is this? It's probably not the way to go.
F of 1.
This is probably not the way. I don't know.
We had an F of 1.
Dang it.
A year.
Hey, this is probably not the way to go.
F of everything.
Dude.
Multiple of F of 4.
So this is actually a pretty big achievement.
Now what?
Okay.
This is so trippy.
So then x
One
equals
that this is
like-
L, alright? I don't know why I picked such a bad letter, but alright.
You should pick O next time.
Alright.
You
Nah,
should pick O.
this is so weird.
Pick that long, the hardest to draw
Okay, no,
Chinese
this is-
character.
there's no solution to that. It's not gonna work.
Take the alphabet as one
Alright.
side. Okay.
I don't know.
Is f of 1 equal 1?
Nah.
Like it's sus.
I got
Highly suspicious.
F of every integer is a multiple of F of F.
Hmm.
This is so sus.
Dancing.
I don't have.
Alright. Let's just do something, alright. Yes, you.
He's gonna do something.
Wait, so x squared plus x is there? Do you know that? Wait. No, we didn't get that.
Guys, found something totally useless. Shit. I found 2/3 equals to f of 1/4 plus function of 1/2.
This is
Yeah, I got that one as
Yeah.
well.
what? Where'd you get that? What?
You solve x equals half and y equals 1.
Wait,
X equals half, y equals 1.
Okay, so you get like
Oh, so that's this thing here. Did you say f of 2/3?
F of 1.
what?
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 The one on the right is x equals 1, y equals half. This
Oh.
one is x equals half, y equals
Yeah, you gotta get all the cases.
What the? Right.
Don't let one slip.
Wait, x equals half 1. Okay, so this is 1/4 plus.
Then
Wait, what?
Oh wait, it's injective. I'm so dumb. I could have used that trick so many times.
Wait.
Wait, what did you get in the end? It was f of
Bruh,
bruh.
that
I am
equals
certified dumb bot.
3/4. Wait, is that what you said you got?
Oh,
Half times 1 plus half, which is 3/2.
but
Yeah.
Alright, I'm gonna do a big brain move.
Wait,
Sub and
I
sub
think
are
yeah, I think
related
it's
to
three
F of K equals F of O. F of O equals K. Okay, that's
Okay, so something gives you 3/4, yeah?
Wait, didn't we know that?
Yeah. But now we know exactly what it is, I guess. It's a quarter plus, and it's a person of
Alright,
interest.
let's go.
O plus L. O plus L.
Nah. What is going on? I completely removed the function on one side. Oh no, this is.
Wait, K equals function of O, so you sub plus function of O. Hell?
Okay, so it's like
Bet, let's go. Oh no, plus function of.
Hey,
But it's not zeros. It is not a zero.
Okay, no, we can't do that because. Wait, no, we can. Yes, we can.
Wait, no way.
Yeah, okay. So then this is f of
difference of function.
1/2 plus.
And then you drag the F out of
Bro, what is going on?
treat the F as a
Equals this thing.
constant.
So let's just
Not as a
delete this
function.
stuff because it's like useless.
Treat it as a
Equals
constant.
f of
Extract the F out of
Oh, now, bro, you know what we
What
should
the
do?
heck?
We should make this into a
What have I done?
function.
What have I
Yo,
done?
that would be insane.
Oh, no.
Fit it until we reach castle.
Yes,
What
let's
have
go.
I-
We
We
keep on
shall
summing it until
Nah,
we reach
we
castle.
somehow will reach a Cauchy function.
I think one more summing in chat order to
Oh no, wait, alright. Alright, so O equals F of O. Don't get it. O plus 1 minus F.
Wait.
What do you get function 2 to be? That thing, right? 1 plus K.
Unit triangles are exactly which values and the sphere and have a sawtooth tile. Oh, well, this is
It's injected. Yeah, that's very important.
Yes. Injective will score points for sure.
What?
Injectiveness will score points.
We're probably at 2
Oh, yeah.
points with injective and that identity
It's
works.
not about solving the question or like getting as many points as possible with the least amount of efficiency, with the least amount of time.
Nah, this is so weird.
You want to put it subjective.
Wait. How is that possible? Wait.
I think it's subjective. You just
How
put
do I
X equals half.
Wait. Oh wait, quarter plus. 3 on 3 on 4.
Well,
3 on 4.
alright. Subjective just means that, like, for every X comes like this. So, there is like.
okay.
Yeah. Alright.
Wait. No.
Oh.
As Y varies, the function varies. Proof is subjective for
Okay.
values of half to infinity. Is this proof subjective?
I don't know.
Sub in x equals half, basically.
That does. I don't think that does. I think you just prove that it's everything above a quarter,
We have that already.
which we have.
Oh, good. My man.
We lost 100 legs. You could do proof that an involution.
Involution.
Mechanic. Well, other functions can't be constant. So it's definitely a polynomial equation. So I'll try something.
Leon, come on. We literally did like the x f equals x
No,
equals
like
y equals half.
not equals half.
Oh, maybe I tried, but like this is the more important case. O equals f over O plus 1.
Function of x equals function 2 into function of x.
I'm not saucy.
I don't have the pattern recognition powers.
Oh no,
Let's try
what
running.
else can we sub in?
Easy.
F,
F over O. Yeah, okay. So you just remove this and
What
make
did I
this
do
big.
here? Okay, let me
Okay,
look at this. 1 half plus 1 over root 2 f 1 minus 1
Yeah.
on root 2 equals
multiplicative.
what?
you're going to mix multiplicative.
Wait, no, this could actually have a
We need a
good
Yeah,
idea.
if you can prove it's multiplicative.
But how do I get it to
Yeah.
you?
Oh,
We are done.
oh yeah, if it's
Actually,
multiplicative, then we're done.
Yeah, because after
Because-
these 100 layers of functions, so
Is it ever nice? It's a nice value.
No, yeah.
Pythagorean
Alright, so
Oh no, but they're like one fifth. Okay, no. Wait. No, they do go up to 1 foot. Surely.
it gives us a better idea though, so then we can case actions.
Wait, what's the thing again?
Most like graphing problems.
3 on
that's-
5
This
one.
this is a
Oh,
this is the graph I
then, like,
sketched it, and then we
yeah, okay. 3 on 5 4 on 5
five and six. Or just like that go.
3. Now we can go back to the f of 1 idea. F of 1 divides every term.
Oh, no, that's not why it's works. No. Yeah, no, that's not. They had a revelation.
Wow.
Time to animate, prove that geometric construction is so decimal. If someone can do that, Alex can do it. Prove that algebraic proofs can go.
No, wait, I'm done. No,
Yeah,
I'm
maybe
done.
that's
Yeah, I'm done. I
still
did.
first 10% of the cake.
So, we told that at the end. Okay, I actually finally solved question 2. That took too long.
We will now mold the x
Why did I take so
y
long on that? That was
by the Morbius theorem. It's the Morbius
Bruh.
theorem.
Oh.
okay. Can't believe.
Where was that?
Mm.
Okay.
Why is this? I can't functional equation. I don't have brain. How to?
Oh, let's go. Ideal.
Integer.
Sus.
Okay, what am
Yo. This is quite weird.
Wait, we know F of
why?
Do we know F of 3
I
on
found-
2?
Wait, no,
Why
no,
is
wait,
there
wait,
two of these?
wait,
There
wait.
shouldn't be.
A.
Oh, right.
There shouldn't be two of these.
Wait, what is F of 3
no.
on 2?
There's 3 on 4.
No, I need F of 3 on 1.
Why is that?
It's just double of 3 over 4.
We can get like
Damn.
Brain, bro.
equals equals x squared plus
Wait, alright, if F of 3 on 2
and
equals.
f mod 1 minus.
Nice.
Ooh.
Oh, why are you seeing K-pop, bro?
You?
Why are you seeing K-pop?
K-pop.
K-pop.
J-pop.
Yo, J-pop. I need to. 3. What is F of 3 on 2?
Okay, but this is only for when it's less than 1. That's not good. We don't want
3 on 2 equals.
Why is it less than 1?
Alright, so.
This is a slight issue.
Oh.
Slight issue.
Okay, I think I proved F of 1 equals 1.
Oh,
What do you do when you restrict?
Let me just make sure. Then F of 3 and
F of x equals x squared plus x f 1 minus x. How? Because you only have x plus 1 constant. This doesn't actually do anything. God damn it, why? Why is it like this? I hate this so much.
yeah, I proved F of 1 equals 1.
really?
I think.
Let
Yeah.
us see.
Okay, so basically, right,
So this doesn't happen.
we're gonna firstly prove this first thing. So if you substitute, let's see, if you substitute x equals y and y equals 1 minus y. Sorry, yeah,
Oh.
sorry. So like substitute, actually it's fine. Substitute x and 1 minus x. So like
Oh wait,
x
that's what I did.
Okay, yeah, so that's the general version
Okay,
of
so
this
then
sub.
that's f of
Yeah.
x equals x squared plus x f 1.
So you're making x plus y equals 1, yeah?
And this only works
doing
from between 0 and 1, right?
Yeah.
Yeah,
So we get x squared plus x by f of 1 minus x
I should trust myself.
is equal to f of x by 1, which is just f of x.
Oh yeah, but then it's injective.
And then you can cancel them x's, I mean those f's.
Yeah, let's go.
And you get x squared plus x f of 1 minus x is equal to f of x, right?
Yeah, I have that here.
Oh, nice.
Yeah,
Nice.
I also have that.
Okay, so now basically, right, I was like trying to find f of 3 on 4, because if you find f of 3 on 4, you can find f of 1 pretty easily.
Yes.
Wait, what? How do you do that?
And like we can do that at the end. But
What?
basically, right,
Wait,
you can
f of
you can substitute
3 on
1 quarter and 3 on 4,
Oh,
right?
okay.
And solve simultaneously, and you get a relation for f of 3 on 4. So basically, if you substitute x equals 1 on 4 firstly, then you get 1/16 plus a quarter f of 3 on 4 is equal to f of 1 on 4.
Yeah.
And then if you substitute x equals 3 on 4, you get 9 on 16
Oh,
plus 3
Wait
on
a
4
minute.
f of 1 on 4
Wait. Yes.
is equal to f of 3 on 4, right? But we know what f of 1 on 4
that's
is.
crazy.
It's 1 on 16 plus a quarter f of 3 on
Oh,
4,
wow.
right? So
Wait,
we can
now it's
substitute
simultaneous
that,
expression.
yeah, we can substitute
What?
the thing for f of 1 on 4
Okay.
and get that f of 9 on 16 plus 3 on 4, big bracket, 1 on 16 plus 1 on 4 f of 3 on 4 is equal to f of 3 on 4, right?
No, okay, so yeah, so basically you're just saying you have two equations and two unknowns, you can find them both.
Yeah.
That's pretty good.
Basically, yeah, you solve for f of 3 on 4 using
Bro,
those
what
two
the-
simultaneous
that's kinda
equations,
insane.
and you get f of 3 on 4 is equal to 3 on 4.
Okay, so 9 on 16
Oh my
plus
god, that's
f of-
insane.
very good.
Look at my ring.
So it's a quarter f of 3 on 4.
Why you're straight?
Animation.
And then like expanding that, it's like 9 on 16 plus
Yeah.
3 on 16, f of 3 on 4 plus 3 on 64.
Yeah, so I'll times everything by 16. Let's see. 1 plus 3 f of 3 on 4 plus 3 quarters
Yeah.
equals 16 f of 3 quarters.
And then yeah,
Then
keep going.
13 f of 3 on 4 equals 9 plus 3 quarters.
Okay. So yeah, that
Huh.
one is what now?
And then you can like get that's equal to 39 over 4, right? 9 plus 3 on 4.
Mhm.
Um,
So f of 3 on 4 equals 39 on 4 on 13.
and 39 is 3 by 13, which is yeah, so that's
Okay,
3
so
on
now
4.
we have f of 2
Whoa.
equals 2.
So now we have f of 3 on 4 equals 3 on 4, right?
Yeah.
So now we can go back to our
Wait, yo, so you can just sub everything in and it works.
so now we can go
That's
back
crazy.
to the relation we had, which was the wait one sec. It was the one we came through by substituting 1/2.
Yeah.
And it was what was that? Oh yeah. A quarter plus a half, f of a quarter plus a half f of y is equal to a quarter plus a half y. That's what we found when we substituted x equals a half.
Like this one, right? Equals 3 quarters.
Oh yeah, that's yes. Wait, hang on.
Wait,
Wait, I think it was like
f of 1.
it was this one.
Quarter plus f of
It was
1 on
that
2
one.
is 3.
Oh, okay. Yep.
And then when you substitute y equals k,
Oh,
I mean
so
y
then you
equals
just get
1.
quarter plus
Wait.
f of 1 on 2 equals 3
Yeah, you
quarters.
get that.
Oh
Yeah.
yeah, you can do it that way, yeah. And we know that 3
Oh,
quarters
yes.
is equal to
What?
f of 3 quarters,
That's-
right? So you can substitute
Okay.
f of 3 quarters into the the right hand side of that equation.
Yes.
So and then you can cancel the f's. So it's like f of is equal to 3 on 4. And then you can solve for f of 1.
f of 1 is 1.
Oh my gosh.
Nice.
Okay,
Oh.
now we have very
So now we have a nice little piece of niceness.
That's very useful information.
Yeah.
Oh, I got like this thing where like by making the like there's like assuming there's like this k such that f of k equals like 2. Then you get that like like if f of k then like you get that f of 2 equals
Wait a minute.
like you get that all the
F
integers
of
are
1
equal to the f of integer.
Wait, f
Uh
of
huh.
1 plus
From-
Wait,
from
then
this?
all integers goes to themselves.
So like I got like this thing that like f of
Really?
like every integer f of integer is like divisible by f of 1. And then like there's like this other multiple.
Oh yeah,
Okay, f
you
of-
do get f all integers equal to integers equal to themselves. You
Yeah,
can do
yeah,
it with
yeah,
induction
you get
on
the-
when you
get-
substitute
You get induction.
yeah, you can do it with induction when you substitute what was that? When you substitute
Okay,
x equals
so
1. If you substitute x equals 1 you can do it by
Okay.
induction.
Yeah.
X equals 1.
Yeah.
Okay, but this is reals. It's kind of hard.
So
How to do reals?
1 plus f of y equals 1 plus
Well then you
y.
can
Plus
just do
y
but
equals
since
1
it's injective, if you prove rationals then you can prove reals. So you just need to prove rationals.
Why? What?
If it's injective and you prove it holds for rationals, then you can prove it holds for reals.
Injective.
Yeah.
Wait, no, that's. Wait, what?
I'm pretty
You mean
sure.
continuous?
Wait, how does that work?
Continuous and oh wait.
Wait, how do you do
Yeah, okay.
continuous?
How do you do continuous?
Hmm.
Oh yeah, you're right. Wait, how do you do continuous?
Oh no. Let's see. How to continuous?
Wait, but it's continuous because it's surjective, right?
Alright.
Wait, what?
It's
Not
Oh no,
necessarily.
not necessarily. No, no, no,
Not
no, no.
necessarily. Ah. What? That's it. Dang it.
I have it.
What does he have?
I have a comment I would like to make maybe a little bit later, but the comment refers to this moment in the problem solving process.
Okay.
I'll bookmark it now so people don't think I'm faking that there's a moment here.
Okay.
It's like, oh yeah.
It's gonna be one of those moments where like you realize you're really stupid and
So
there's like a
close.
simple solution to go forward. I feel
We'll
like it's
see.
gonna be like
Well,
that.
I got that like for any rational.
Touchy stick.
Mm,
Touchy stick.
crazy.
We know f of k equals k for all integers.
Yeah.
Then if you substitute p and q, let's see.
Leo, what should I do?
That's big.
What's the big functional equation?
You know why? Sub p equals 1 and q equals 1.
Bro, we're doing it for us, so we already got.
I don't know how to do rationals.
You get function of 3 over 2 equals q.
Could use the x plus
yeah.
y.
Oh wait. Oh yeah. Show me.
Plus y. Okay, so if we use this, then we might be able to get.
Oh.
Who is Seirei Gensuki?
That's not quite right. Yeah, we still need that circle. Dang it. Ah.
Interesting. Alright, second. Oh, where's that? Oh, wait. I think I can. Wait. Wait, because if we prove it for all rationals less than or equal to 1, then we can use the induction thing to get it for all rationals,
Yeah.
right? So then we can
Wait,
yeah.
can we?
Yes, we can because of the integer thing.
Because then we can use the one that's like f of so y squared plus y by 1 minus y is equal to f of y. And do the simultaneous thing like we did for 3 on 4 and 1 on 4. And maybe get that f of rational less than 1 is equal to rational. Wait.
I got like
Wait, maybe that's how you can prove reals. Wait, let me see.
f of 1 plus f of p over q equals 1 plus p over q.
Can I write on this?
Yes.
Oh, thank you.
Yeah, we do like that.
Y squared plus y plus
Dang it. X to be something. We get. Oh wait, we already have integers, so it's easy. Okay, I'm dumb. I am dumb.
Oh yeah, we do.
Yeah, okay, I'm just dumb. Never mind. Okay. F of equals x squared plus x. What's really in it? F of x squared plus x equals x squared plus x. No, that's just that's still integers though. Damn it. Oh, damn it. What? Oh. Wait, but we can invert this because we know that everything above 1/4 exists. So wait, if we could. Okay, no, that's not like. That's the step in the
Oh.
okay, and then we can divide this by right?
It looks like we're all doing well.
X squared plus x1. Hey, wait, F inverse is just this, no, it's like this. Oops. Okay. Now, how do you get to rational ones? It's kind of hard. There's only like one product.
Right, I'm pretty sure I got it, but I just made a mistake.
Yeah, I'm pretty sure as well.
So what did I do here?
This is too hard.
Maybe it's time for my comments.
That's why minus y cubed minus y squared over 1
That's on Y.
x squared.
Okay, how about I make some comments without even seeing how it goes, but like, yeah. Okay, so
Okay.
it depends on how you view it. You can think, I kept my mind deliberately clear of the solution so I can give you genuine reactions to your progress. Or you could perceive it as I couldn't solve the problem. Okay, depending on your view of me. Okay, so as soon as I heard Anthony say identity works, yeah. So I'm like, okay, that's good. And then I heard injective, okay, and I'm like, oh, definitely getting points on this problem, okay. Like, see, for identity you might not get any points, but for identity and injective you'll get at least 2 points. Okay, it's weird that identity is like worth 1 point if you maybe combine it with something else. And I guess the reason is because once I heard injective, I was convinced that it was only the identity. Okay, so that was when I was convinced of that. and then you had these nice ideas with half, putting the half in. You got sort of subjective. And some formulas with 3 on 2, realizing that like f of 1 equals 1 is a nice milestone. Okay, so all that was kind of nice, but then when you proved, so I guess when you proved that f of 1 equals 1, that was in my mind when I realized the problem was solved. Does that make sense? So once you communicated this solution to me, I was like, okay, the problem is now solved. It's just you got to sort of see the solution in the right generality, right? So the reason, because I guess the reason I think that the problem is solved, even though I haven't checked it, right, is because, like, why can't you just do the same thing for other numbers between 0 and 1? Why does it have to be a quarter and 3/4, right? So if you use that same idea, because they're making the most of what you have, right? Instead of using 3/4 and a quarter, you just have 1 minus x and x, right? You still get a simultaneous equation.
Oh. I am.
You just use the.
I'm assuming that's what you did. That's what you did, right?
You just do the same.
Yeah, you just do the same thing and it comes out.
Oh.
Yeah. That's then you get f of 1 minus y equals f of 1 is equal to 1 minus y for all y. That's in between 0 and 1, and then you can apply the what is it called? Induction. Okay, for all reals, because it holds for all reals.
Oh damn. Let's go.
Boom.
All right, let's go through your solution.
Yeah.
So
Nah, the half part was the most important part.
Well,
Yeah.
how do you even motivate the half part? I didn't
Wait,
So
when
you
you get the f of half equals
You
1 half,
motivate the half part because if you substitute x equals y for the half,
then
Then you can
there's
use
like the
objectivity.
1 only.
yeah.
Yes. Oh yeah.
So
Okay.
if
Oh yeah, it's just because f plus 1. I have a severe lack of experience with functions.
Me too.
I need to do more.
Makes us equal, I guess. Right here.
Yes, don't rely on your experience with problems of this type. Rely on your experience of mathematics. Rely on your mathematical
Yes,
You
maturity.
should start a quote book.
Michael's
Where's
quotes.
Oh, I remember
Random
I did
quotes
write a
from-
list of quotes.
from
Michael's
Zoom class.
quotes.
Zoom class.
I can't remember. Hold up, I need to find that.
Yeah.
What a legendary song.
Okay, so sub it in how you like, I guess. I will sub it in like this. So this is x's between. This is how we say it in this in the new the interval notation.
Geometry.
Wow.
Yes.
Okay. In the wait, no, I need to actually try these. Like
Very good.
How do they even come up with these problems?
I don't know.
using the large brain.
But I would imagine that how I would come up with these problems, I kind of wouldn't be okay. I mean, depends if I really wanted to put effort into actually coming up with problems, or see if I was just doing research, I would probably just come across certain little problems that I had to solve, and I would think of
Okay.
maybe that doesn't need anything very special to solve it. A high school student could do that, and I just submit it to some Olympiad. But I think if you wanted to put in effort to make a good problem, you would then like think about what a student would think about while looking at this problem and stuff like that, right? And try
Yeah.
to make it a bit of a journey. Yeah, it's almost like it's like the Olympiad problems are kind of like research problems in high school maths that have no other place to be published.
Wow.
Okay, this is actually nice.
Like this, yeah.
It actually is.
Yeah, so I'm sorry that I spoiled it for some of you, but
No.
the general principle is when someone gets it, that's the end.
Okay.
So like plus 50 rating points right here.
Pardon?
Probably.
Plus 15.
Oh yeah, if stop is infinite, there will be always be a notion of closeness.
What's going on?
Well, they're quoting.
Michael's son quotes.
It'd be so long.
Bro.
Stop is infinite. There will always be a notion of closeness. True. True that.
What?
I think I was saying that if stuff is sufficiently infinite, or like, God. Yeah, I guess it could be discrete if it's countable. Okay, so yeah, so to do some factorizing.
Notion of closeness.
Then X is big step. Big step because my
Just realized Amok Senior is in like 10 days or something.
Yeah, I thought you were gonna say. I just realized that senior contest isn't as hard as I thought it was.
Just realized
If
senior contest is
only.
too hard for
If
me.
only.
It's too hard for
Look
me.
at it, I'm
No, like this is very
how's AMC?
boss-like treatment
Boss.
of.
Well,
Yes.
How's AMC?
I threw AMC so hard.
I mean,
Oh, same.
I
Oh,
solved all
wait,
five
there
of
was
the
this
last
really weird
questions
question.
except I only
Wait,
got
Alex,
two of them
Alex,
right.
you know question like 30. That one was so weird.
I love question 30. That was the best
What's
AMC
question
problem I've seen.
30?
oh yeah, actually, so yeah,
That was
I should have
actually
mentioned, but you
Well,
could have
I
actually
was
done
like,
senior.
yeah.
You could have done senior
Which one did
AMC
you
if you
get?
wanted to, but
Oh, I did do
30.
senior
Oh.
AMC.
oh really?
Yeah.
Up to 64.
Oh,
And I
nice.
kind of
Yeah,
regretted it.
It's so weird.
It's such a nice.
Bro, you have to.
problem.
I solved it by defining a function.
What's the
What
question?
are you talking about?
How do you
Bro,
solve
it's so weird.
What are you talking
I just
What's the
observed that.
It's like the AMC Q30. Like,
Oh.
That was
I
such
don't,
a
I don't
nice
understand how we were meant to
I
solve
like
it
it.
during the
What was
like
the
during
question?
the exam. Did they want me to like count all of the parts or something?
What's the question?
Bro,
Yeah, you basically just have to like recognize.
no, like it's so weird.
Wait, do I get a
Say you
cue?
The
have
way
to
I solved it
wiggle
after, it was like
something.
you define a function for each column, and then there's like it's a bar, like a function that only gives two outputs.
Yeah.
And
Wait, is this what you got?
times that
Yeah,
16.
Oh, I solved for x minus
You
1.
guys
I
want
just did
But
this.
yeah, it'd be something
like
like
a
that.
vision.
Actually, oh wait, that's kind of weird. Oh wait, oh wait, oh wait.
Oh, I solved
Oh,
it.
so this is the same as the denominator.
64.
Yeah, I got
64.
That's the same as the
Oh,
Oh
denominator.
yeah, wait. Oh wait, it's 2x
Really?
squared.
Guess what I got?
So this is x
Oh wait, no
squared
x squared.
Guess what I got?
minus
wait.
Well, I
x
just did
plus
this.
1. Yeah.
Oh yeah.
Okay,
X. Oh yes, nice. Okay, yeah.
Right, so we just gotta check that
I
x
did
squared
like
minus
this.
x plus
I saw
1 is
I
not
did like
0.
this
How do we
was
know that?
one. This and this was 1. So like I guess 16.
I
just
like rip me.
Okay, I just did this. I realized.
Wait, doesn't
Okay,
it?
you have to go this way.
So the
and start like
discriminant
that.
is
Okay, and
1
then when you
minus
stop, this could be a 0.
4.
But like when you
4.
stop, you have to go
Yeah,
up.
it's negative.
Okay, yeah.
And when you go up, you have to do
There
this.
we go.
Yeah.
So it's only got magnitude
Okay,
solution.
so I just separated it into a bunch of wiggles.
Yeah.
And then I just defined the dividers as like on or off to define where the wiggles are.
Yeah, this is like
And
plus
I
a
realized
quarter
you
is
can't-
positive.
You can't
And then
choose the
plus
last
1 is
divider
even more
because-
positive.
Yeah.
You have to go.
Alrighty.
You have to go.
Yeah,
Yeah.
so if you
Okay,
know
I
it, if it's an identity on an interval, as you say, right,
Mhm.
then any of these other
So
things
what I
will
did
solve
was,
it.
like, so I
Yeah, because we
find
can
a
do the
function
induction.
for each
Induction.
column such that
Just do
like,
this, yeah.
find
Yeah.
the first square you
So
go
if
in
so,
that
okay, then you
column, right?
suppose
Alright,
y,
so this one is like this one you have to go here and this one you
like
have to go
y
here.
is
So for all of these columns, you can't go middle column first.
is
Yeah, because otherwise
less than 1. Yeah,
it's one
Yeah.
of these and then you just shift it to times that.
you got f of
Such a stack.
quarter
That's
plus
actually
y
an
on
interesting
2
solution. Interesting.
equals a quarter plus y on 2. Yeah,
Mhm.
which basically tells you that it's the identity from a quarter to
What's
what?
what?
wait
Wait.
quarter to
Wait a second.
Quarter plus y.
Wait, but if you substitute x equals 1, I'm pretty sure you can get f of 1 plus f of y is equal to 1.
yeah, this thing here, right?
Oh.
Yeah, that's it, and you can
F of
do the
1
f of 1
plus
equals 1.
1 plus y, yeah.
Yeah.
Yeah. Okay. So now it's just a
And
lot
then-
of.
And then
No.
it's induction.
Yeah, so then all the things, so if you take y is less than 1, right?
Mhm.
哎，我们今天很多人都来了，好像。
Oh yeah, 1 plus y equals 1 plus y. Nice.
But now this is for this 1 plus y is bigger than, it's all the values bigger than 1 and less than 2. You know? And then we'll keep going. So we already had it for all the integers, so oh yeah, we have it for the integers, so we can do like equals here, yeah,
That's so nice though.
and then like that, and then every interval.
Yeah. It's actually such a neat problem.
Actually, I have a comment. So it was not obvious that it was injective. Okay, so that's why the first step was so shocking. I think if you do it, the problem's enough. Because the first kind of thing you think with these problems is kind of what Leon's saying. It's like when the reals, all the reals, you start subbing in 0 and stuff, and you sub in 0, you start thinking like, oh, it could be the 0 function as well, right? So if you think like that, then it's not obviously going to be injective on the first step, right? But it looks like it is. So injective simultaneous equation moving up the intervals.
Nice. Nice solve.
Very good. Live solve. You did it.
Lipton.
Hmm.
They're getting more rights than us.
Oh,
I have no rights. You're playing Tetris. You have no rights.
So that's not very nice. They have no rights.
You have no children. Have no
I have
rights.
left